Okay, Algebra 2, this is the second half of 4-3 notes. We're still doing division, but this is synthetic division, and synthetic division you will like a whole lot more than long division. Long division is kind of a doozy. Synthetic division is a lot cleaner and nicer. And you're probably wondering why I don't start off with synthetic division. And the reason why they don't have us do synthetic division before long division is because you will not be able to do synthetic division in every case. You will be able to do long division on any two division problems that you want to, or on any division problem that you want to. But synthetic division will only work for certain types of problems that you are dividing. Okay, and I'll talk to you down here when we get done with some synthetic division problems and kind of show you when you can and when you cannot use synthetic division. So that's what we're getting to. Synthetic division is a simpler process for dividing a polynomial by a binomial, okay? So I'm going to go ahead and I'm going to explain this box over here because this gives a really good illustration of what synthetic division looks like. So the thing that I am dividing is x cubed minus 2x squared minus 8x minus 35. And what I do is what I'm dividing by is x minus 5, okay? So here's the deal. What we first want to do is say x minus 5, and I want to set him equal to 0. And when I set him equal to 0, we add the 5 to the other side, so x is actually equal to a positive 5. Kind of like we do when we're finding the zeros, when we have them factored down and stuff like that. You set him equal to 0, and he switches the sign, okay? So what I'm going to do is I'm going to actually use the number 5 instead of the number negative 5. I'm going to use a positive 5, and the way that synthetic division is set up is you set him up with a box. Follow my pink lines here. A box that looks like this. He's kind of like the reverse box, kind of the opposite direction than a long division. And we're going to set 5. We're going to camp him out over here on this side of that box, okay? We're using positive 5, not negative 5, so keep that in mind, all right? Then these numbers that I want to start with over here are the numbers that come from the numbers that are in front of the x's. These would kind of be like A, B, C, and D if we were writing it out, okay? The number in front of the x cubed is 1, so that's where this 1 comes from. Then I have negative 2, that's where negative 2 is. Negative 8 goes here, and negative 35 is my last number, okay? So that's just to set him up and get him ready to go. We've got 5 on the outside, and then those coefficients all together, okay? So we're ready to do our synthetic division. He is all set up and ready to go, okay? The very first thing that we do is we drop the first number down, and he goes there. That's awesome, pretty easy, just drop that number down. Then what I do is I take the 5 and I multiply him by the 1, and that number goes here. 5 times 1 is 5. Then I do what it says here, I add those two numbers together. So negative 2 and positive 5 will give me positive 3. Then I do the process again. 5 times 3 will give me 15, and that number goes here. Then I add the negative 8 and the 15 together. Negative 8 and 15 gives me 7. I repeat the process again. 5 times negative 7 will give me 35, and that number goes here. And the last thing I do is negative 35 plus 35, that will give me 0. And that's what he looks like there, okay? So the entire time I'm multiplying, multiplying to get here, adding, multiply, add, multiply, add, okay? That's the entire process of synthetic division, okay? Now, my final answer, so I always put this last number here in the box because that's 0. That's what my remainder will be. So in this case, we don't have a remainder. And all I want to do is take these 3 numbers that I have here, and I want to put them back and insert the x's back into the function, okay? So the way that I decide that is x to the third power. What I was doing is I was taking an x to the third power, this x to the third power, and I was dividing by an x to the first power. So when I'm dividing that out, I take that x to the third divided by x, and that will give me x squared. It's 1 less than the x to the third power. So this first number here, this will be my x squared number. Then I just go down from there. 3 is going to be my x number, and 7 is just going to be the number, okay? So the 1 that's listed here, this will be 1x squared. The 3 that's listed here, that will be plus 3x. And the 7 that's listed here will just be plus 7. And that's how I put him back together. Okay, so I strip the x's away from him to put him inside of the synthetic division, and then I take the x's, or I put the x's back in after my synthetic division is done. Okay, so you'll be able to see that a little bit better when we start from scratch over here in example 5, but I just wanted to kind of introduce that process to you so that you could kind of get an idea of what we're doing here. Okay, so synthetic division, we are dividing by x minus 4. So the first thing that I'm going to do is I'm going to say x minus 4 set equal to 0. I would add the 4 to the other side, so x is equal to a positive 4. And that positive 4 is the number that's going to go outside here, right up there at the top. Okay? Then, to list out all my numbers going across here, I get those numbers from these guys inside of here. Okay? So I start with 2 is the number in front of the x cubed, negative 13 is the next number to come, and leave kind of a little bit of a space in between those two so it doesn't look like those numbers are running together. Okay. Then I have 26 as my next number, and negative 24 is my last number. Okay. All right, so I have him set up, ready to go, and then I'm just going to start my division. Okay, so I'm going to drop my 2 down first. That's the first thing that I do. Done. Okay, then I multiply. 4 times 2 is going to be 8, and I'm going to put that in this spot. So 4 times 2 gives me 8, and that goes there. If you need to write the work in there, you sure can. Then I add these guys. Okay, so plus 13, negative 13 plus 8 is going to give me negative 5. Then I multiply again by 4. So that number goes here. 4 times a negative 5 is going to give me negative 20. Then I add those two numbers together. 26 plus a negative 20 is going to give me 6. Then I multiply again. 6 times 4 is going to give me 24, and I add these guys together, and that gives me 0. Ha, I'm another one that has a remainder of 0. I like it when that happens, okay? All right, now I have my numbers 2, negative 5, 6. Those are my 3 numbers that I have when I do my division. I have to put the x's back in there. So I started with x to the 3rd power, and I was dividing by x, okay? X to the 3rd power divided by x is going to give me x squared. So this first number here is going to be an x squared. Really, it's just 1 less than what you started with. X to the 3rd power, 1 less than that is x squared. So this first number here, this 2 is going to be an x squared. This guy is just going to be an x, and this guy is just going to be my number. Okay? So to put those numbers back in there, this would give me 2x squared, that's what this guy is, minus 5x, and then a positive 6 at the end, and that's what I am left with after I take these two and divide them out. Okay, 2x squared minus 5x plus 6. It's a lot faster of a process than what long division was up here. Okay, and really after you get the hang of it, you can really get to going really fast with this. Okay, all right, is this last example? Like example 6, last example. Okay. 3x plus 1 is what we are dividing by, okay? Now, this one's just a little bit more challenging, but we still can do it. 3x plus 1, we set that equal to 0, okay? And when I do that, I subtract the 1 over, okay? So 3x equals negative 1. And then if I divide by 3, x is equal to negative 1/3. So even though it's an ugly fraction, I can still do it, and I can still put the negative 1/3 on the outside there, kind of like I did with the 4. Up here, okay? And then I just put my coefficients out like this. So I have 3, negative 5, this guy is a 1, and this guy is a 7, okay? Now, we need to make sure, yesterday I told you when we set up this second example for long division, I said that if we don't have a value here, we have to insert a 0 in there, okay? So like an x to the 5th and x to the 3rd, I didn't have an x to the 4th power, so I had to plug a 0 in. Okay, so let's check this problem and make sure that we have everything that we need. So x to the 4th power is where we're starting. I'm just going to go ahead and write my 3 down, but let's make sure that these go in order. So I have an x to the 3rd power, that goes in order. I can put my negative 5 down. Then I x to the 2nd power, that goes in order. So I have a positive 1. Then x to the 1st power, well, that still goes in order, and that's a 7. But I don't have a number that doesn't have an x attached to it. Like this one, normally we have x to the 3rd, x to the 2nd, x to the 1st, and then just your number. I don't have my number. So I have to put 0 in there for just that regular number, okay? So if I was missing any one of these values, like if I didn't have an x to the third power, I would plug a 0 in that spot, okay? Same thing with us not having just a regular number. We have to plug 0 in that spot, okay? All right. So the first thing that I do when I start my division is drop the 3 down, and then I need negative 1/3 of 3. So 1/3 of 3, if you need to use a calculator to do this, you sure can. A third of 3 is just 1, and since it's negative 1, or since negative 1/3, it's going to be negative 1. Then I add these guys together. So negative 5 and negative 1 added together give me negative 6. Then I want negative 1/3 times negative 6. A third of 6 is 2, and a negative times a negative gives me a positive 2. And I want to add these guys together. So 1 and 2 gives me 3 again. And we said negative 1/3 times 3 was negative 1 in this spot. Then I add these guys together. 7 and negative 1 gives me 6, okay? And then negative 1/3 of 6 is going to be negative 2, okay? And 0 plus a negative 2 is negative 2 again, okay? If you got lost in that process, rewind and see if you can get yourself back on track, okay? Negative 2 is my remainder. In this top problem, we didn't have a remainder. It was 0. But in this one, we do have a remainder, and it's negative 2. So I'll kind of show you here in a second how we write that out. But what we were doing to put our x's back in, we were taking x to the fourth and dividing an x out, okay? X to the fourth divided by x is x to the third, or really we just do 1 less than x to the fourth. So this guy is going to be my x to the third number. This is going to be my x squared number. This is going to be my x, and this is just going to be my regular number. This guy is my remainder, okay? So let's put all our numbers back in there. 3x to the third power is what I start with. Then this guy is negative 6x squared plus 3x. This 6 is just my number. And then I have a remainder of negative 2. So I'm going to put minus 2 over the thing that I was dividing by was 3x plus 1. So it's going to be negative 2 over 3x plus 1. Ooh, that's kind of written really small. But this is what my solution is going to be with my remainder put in there. So kind of ugly, but it's still better. Synthetic division still looks a lot better than what the long division did, which was up above here. Okay? All right, so 2 synthetic division problems we just had here. 0 is my remainder up here. Whoop. And I actually had a remainder down here. All right? Note, synthetic division will not work when dividing this function by something that is bigger than just 2 pieces. So notice that we were able to do synthetic division when we were dividing by like 3x plus 1 because that's a binomial, okay? Up here we were dividing by x minus 4. That's a binomial, okay? Each one of these were x to the first power, x to the first power down here, okay? And this 3x plus 1, x to the first power. But down here, if we try to divide by x squared, minus 5x plus 6, this is 3 pieces, and it's an x squared. We're not able to use synthetic division to divide, because remember the first thing that we do when we're doing synthetic division is we set this guy equal to 0. And I can't just solve that like I did up here by setting it equal to 0 and solving for x. I can't just do that process when I have these 3 pieces and an x squared, okay? So synthetic division will not always work. Long division will always work, but synthetic division won't for problems that are ugly like this, okay? So 3 homework problems. They're on the back side of that long division. Brad. And you need to go ahead and set these guys up and find your solution, okay? One thing that I will bring up here is in this first problem, we have x to the third, we have an x, and then we have a negative 6. We don't have an x squared. So you will need to insert a 0x squared in there. And then list those numbers out in this spot. Okay, so just to get you started, the first number that I start with is 1x to the third power. So a 1 is going to go in this spot. Okay, then we said 0x squared. I have to put a 0 in the second spot. Negative 7 is going to be my third number, and negative 6 is my last number. So that 0 was my x to the second power that I needed to insert in there. Okay, if I set this guy equal to 0, x is equal to 3, and I put 3 on the outside, and then I start with my synthetic division, okay? Make sure you put your X's back in and write your solution in this spot, and then you'll have the next couple problems to do, okay? Long and synthetic division are kind of difficult, so don't feel bad if you're kind of struggling a little bit. Just do it the best you can. Try to come up with a solution or attempt each of the problems, and then we'll kind of do some damage control on Monday. We'll go back through and maybe get some whiteboards out and try to do some of these problems on whiteboards, okay? Just do the best you can.